Hi everyone. In this video, we're going to dive into data modeling, and throughout this course, we'll focus on a powerful technique called dimensional modeling. What is dimensional modeling? Dimensional modeling is a data structuring approach used in data warehouses. It organizes data into two key types of tables, facts, which store measurable business metrics, and dimensions, which provide descriptive context. This design helps optimize performance for reporting and analysis. Dimensional modeling aims to simplify complex data structures, improve query performance, support flexible slicing, dicing, and aggregation, provide a business-friendly view of the data. Core components of dimensional modeling. Dimensional modeling is built around two main types of tables, fact tables and dimension tables. Fact tables. Fact tables contain the numeric, measurable data about business processes. A common example is an orders or sales table, which includes information such as sales amount, product, customer, and order date. Key characteristics of fact tables include: they contain foreign keys that connect to related dimension tables. They store measures or metrics used for analysis. They are usually large, often containing millions of rows. The data is typically additive or semi-additive, meaning it can be summed across dimensions. Dimension tables. Dimension tables store descriptive attributes about the business. They help break down aggregated measures and allow users to slice and dice data from different perspectives. Key characteristics of dimension tables include: they contain textual or categorical information. They include primary keys referenced by the fact table. They provide the who, what, where, when, and why context behind the numbers. For example, a product dimension table would include details like product number, product name, and category, where the product number acts as the primary key used by the fact table. Now let's open a Power BI file containing the orders table and take a look at how dimensional modeling works inside Power BI. As we learned, fact tables store numeric data that can be aggregated in reports, and they often contain millions of rows. Dimension tables, on the other hand, contain descriptive information that helps us slice and dice the data. A single large table is never an effective data model. By breaking that large table into dimension tables, we can significantly improve performance and create a cleaner, more flexible data structure. When we examine the orders table, we can see columns for customer number, product information, store number, and order date. If we scroll to the right, this table clearly contains a mix of both fact data and dimension attributes, making it a perfect example of a table that needs to be modeled properly. To create our dimension tables, we'll transform this data using the Power Query Editor. On the Home tab, click Transform Data to open the editor. We'll start by creating a product dimension. Right-click the Orders query and choose Duplicate. This creates a copy named Orders 2. Rename this table to DIM Products. Next, hold the Control key and select the columns Product Number, SKU Description, and Part Number. Open the Remove Columns drop-down and choose Remove Other Columns. Now the table contains only these three product-related fields. You can reorder the columns by dragging Part Number into the second position. Since the combination of Product Number and Part Number uniquely identifies a product, hold Shift to select both columns, then right-click and choose Remove Duplicates. However, Power BI does not support relationships based on multiple columns, so we need a single unique key. To create one, go to the Add Column tab, open the Index Column drop-down, and choose from 1. This generates a new index column starting at 1 with increments of 1. Rename this column to Product Code, and move it to the first position. This will act as our surrogate key. In real-world scenarios, you may need additional product attributes, such as product category, that don't exist in the orders table. In those cases, you can import another product table and merge it with dim products to bring in the missing columns. Once everything looks good, click Close and Apply. We've now created our product dimension table, dim products. Now let's create a date dimension in Power BI. Again, open the Power Query Editor, right-click the Orders table, and choose Duplicate. Rename Orders to Dim Date, which will serve as our date dimension. Hold Shift and select the columns Order Date, Year, Month, Quarter, Week of Year, and Day. Open the Remove Columns drop-down and remove all other columns, leaving only the 6 date-related fields. Highlight the Order Date column, right-click, and choose Remove Duplicates. This guarantees that each date appears only once and can serve as a proper primary key. Click Close and Apply to complete the date dimension. Using the same approach, we can create additional dimensions such as customers and stores. That brings us to the end of this lesson. In this video, we introduced dimensional modeling, reviewed the characteristics of fact and dimension tables, and built 2-dimension tables from our fact table. In the next video, we'll explore the star schema and snowflake schema in Power BI. Thanks so much for watching, and don't forget to subscribe to the channel to support our work and stay updated with upcoming Power BI lessons.